Welcome to Sources classes. Today we will be dealing with pricing with market power. Let's see a question. In this question we have Elizabeth Airlines EA flies only one route, which is Chicago and Honolulu, and we are given the demand is Q equals to 500 minus P. The cost of running each flight is $30,000 plus 100 per passenger. We need to find the profit maximizing price that EA will charge and how many people, that is the quantity, will be on each flight, and also the profit for each flight. In order to find the profit maximizing price that EA will charge, we need to first find the demand curve in inverse form, that is P equals to 500 minus Q. We know that the marginal revenue curve for a linear demand curve will have twice the slope, that is marginal revenue equals to 500 minus 2Q. Since the cost that is incurred by the airlines for one more passengers is $100, here marginal cost is 100. And now setting the marginal revenue equals to marginal cost, that is MR equals to MC, we find the profit maximizing quantity, that is 500 minus 2Q equals to 100, or Q equals to 200 people per flight. Now substituting the value of Q in P, we get P equals to 500 minus 200, or P equals to $300 per flight. The profit equals to total revenue minus total cost, which will be 300 into 200 minus 30,000 plus 200 into 100. This, on further calculation, we find that it's $10,000. Therefore, the profit is $10,000 per flight. Moving on to the next question. Now, in the next question, we see that Elizabeth learns that the fixed cost per flight is $41,000 instead of $30,000. Now, we need to figure out how long will she stay in this business, and we need to illustrate our answer using a graph of the demand curve that EA faces. The average cost curve when fixed costs are 30,000 and the average cost curve when the fixed costs are 41,000. Now we can see that an increase in fixed cost will not change the profit maximizing price and quantity. However, if fixed cost per flight is raised to 41,000, EA will lose $1,000 per flight. The revenue generated, that is $60,000, will now be less than the total cost, which is $61,000. Hence, Elizabeth would shut down as soon as the fixed cost of 41,000 comes into force. From the adjoining diagram, we can see this. Now we see a case of differential pricing. Here EA finds two different types of people fly to Honolulu. Type A is a business people with a demand of QA 260 minus 0.4 P, while type B are students whose total demand is QB equals to 240 minus 0.6 P, and it's given that the differential pricing is possible. We need to graph each of these demand curves and their horizontal sum and figure out what price will EA charge the students and how many of this each type are on each flight. And lastly, the price when EA charge other customers. Now first we find the inverse demand functions. PA is the demand function of type A, which is PA equals to 650 minus 2.5 QA, and PB equals to 400 minus 1.67 QB. Now, using the fact that the marginal revenue curves has twice the slope of a linear demand curve, we write MR A equals to 650 minus 5 QA, and MR B equals to 400 minus 3.34 QB. Now to determine the profit maximizing quantities, we said marginal revenue equals to marginal cost, that is 650 minus 5 QA equals to 100, giving us QA equals to 110, and 400 minus 3.34 QB equals to 100, giving us QB equals to 90. Now using QA and QB and putting it into this demand functions, we find the appropriate price in each sub-market, that is PA and PB, where PA equals to 650 minus 2.5 into 110, giving us $375, and PB equals to 400 minus 1.67 into 90, which giving us $250. Thus, we see that since such distinguishing is possible, Elizabeth finds it profitable to charge a higher price to A and a lower price to B. This is because these type A travelers have a less elastic demand at any price. Let's see the graph. Taking price on the y-axis and Q on the horizontal axis, we see that we have 2 points on p-axis, that is 650 and 400, and we have 260 and 520. You can correlate the prices that we had obtained earlier mathematically along with this graph to find the accuracy of the sum. Moving on to the next question. Now we need to find out EA's profit for each flight and whether she would stay in business, and to calculate the consumer surplus of each consumer group. Now with price discrimination, we find the total revenue as TR equals to 90 into 250 plus 110 into 375, which equals 63,750. Now the total cost is 41,000 as earlier from the question, plus 90 plus 110 into 100, giving us $61,000. And now we need to calculate the profit. Pi equals to 63,750 minus 61,000, giving us $2,750. Now consumer surplus for traveler A is 0.5 into 650 minus 375 into 110, which comes to 15,225. Similarly, for type B, we have 0.5 into 400 minus 250 into 90, giving us $6,750. Thus, total consumer surplus equals to 21,875.